Okay, this is Giancoli AP Edition, 7th edition. We're in Chapter 10, Fluids. Working on Problem 5. This is a Level 2 problem. The problem reads, a bottle has a mass of 35 grams when empty and 98.44 grams when filled with water. When filled with another fluid, the mass is 89.22 grams. What is the specific gravity of this other fluid? As with most problems, we're going to identify what we have. Now we've got several different masses running around here. We want to make sure we use subscripts to distinguish our quantities. That is the mass of the bottle itself. This is the mass of the water plus bottle. And this is the mass of some mystery fluid plus the bottle. We'll come back to those in a minute. What they're asking us for is the specific gravity of this mystery fluid. Now, early in the chapter, they define specific gravity as the ratio of the density of a given substance, in this case our mystery fluid, compared to the density of water. And it is well known, or you can Google or check the table 10.1 earlier in the chapter. We know that the density of water is equal to 1 times 10 to the third kilograms per cubic meter. So that'll come in handy. Now, we don't know the density of our mystery fluid. We don't know the specific gravity. Obviously, that's what they're asking us for. So this could potentially become a problem, but you've been working with physics long enough at this point, you should know that oftentimes values will disappear and we don't really need them. We're going to take a look at this equation here. Now we know that density is defined as mass per unit volume. We're going to use that to make a substitution in our equation up here using the appropriate subscripts. The density of our mystery fluid is the mass of our mystery fluid divided by the volume. Now I'm not using subscripts here. I could. That could be the volume of the fluid. But as you read the problem, you'll notice that we are filling the bottle in both cases. And so the volume is the same for both the water and the mystery fluid. So I don't need to distinguish between the two different volumes. For the density of the water, we're going to replace that with the mass of the water divided by the volume. Now we did have the density of the water. We had a number for that. But it's actually more convenient in this case to use this relationship so that I can make the volumes cancel. Then I have just the masses, or I also have a number up here. That'll save me some calculations and some runaround. Just another good reminder of why we save our numbers for the end in all these problems. So those volumes cancel. I find that for this problem, in this case, it might be mass of the fluid, the mystery fluid, divided by the mass of the water. But again, that's because the volumes are the same. Now looking at the values I have up here, the numbers I actually have are the mass of the water bottle and the mass of the fluid in the bottle. So rather than make this real formal, I'm just going to subtract off the 35 grams for the bottle in each case as I enter my numbers. You can do this separately if that gives you some heartburn. Remember, specific gravity is a dimensionless ratio, so it should make sense that these masses are canceling. The fact that these are in grams is not an issue because they're the same unit, so they will cancel, and I don't need to do any conversions to kilograms or anything like that. So for the mass of the fluid, I'll use my 89.22 grams here and subtract off those 35 grams, leave me with 54.22 grams for my mystery fluid. And then for my water, I've got 98.44 grams, subtracting off the 35 grams for the bottle. That's going to leave me with 63.44 grams. We can confirm here that our units are canceling. It's going to give us our dimensionless ratio. A little mental math will tell you this is going to be a number a little less than 1. This object is less dense, this fluid is less dense than water. It would float on top of water if it did not mix. So now you pick up your trusty calculator and calculate a number. After entering those values, dimensionless number of 0.85447-ish and some change. given that our original problem has significant figures of actually 4, which is more than usual, we're going to go ahead and round. These are all approximate. We're going to round this number to 4 significant figures, 0.8545 for our specific gravity of our mystery fluid. And we're done with this one, moving on to the next.